So I'll give a brief overview of using satellite imagery for wombat and rabbit warren detection in the Nullarbor Plain. I'd just like to start by acknowledging the many communities that form the far west coast as the traditional owners of the Nullarbor region and pay my respects to their elders, both past and present. So in arid and semi-arid Australia, burrowing mammals are prominent ecosystem engineers that shape and modify the landscape. So notably, we have species like the wombat, which is a native species of conservation priority, and then rabbits, which have more negative implications for biodiversity and productivity. Particularly, they reduce palatable resources for species like the wombat. So interactions between the species and their environment are particularly interesting where they overlap, but in regions that are quite remote, we lack a lot of broad scale and detailed information about where these species are. And this is particularly in the Nullarbor Plain, which is our area of interest. It's a bioregion that is mostly remote and arid, and it extends across South and Western Australia, and it has the most extensive wombat population here, and rabbits are widely reported, but access to the region is extremely limited, and field data can be quite expensive to attain and minimal in its coverage, leading to very sparse empirical data that we can work with to understand their broad-scale distribution in these areas. So ideally, we need more broad-scale methods for data collection that we can integrate and use. So we've been exploring whether open source satellite imagery like Google Earth and Bing Maps could help to detect rabbit and wombat warrens as sort of these fixed indicators of occupation. So in open landscapes like the Nullarbor, rabbit warrens can often be distinguished from wombat warrens based on features such as size, colour, and structural differences with spoil mounds and entrances. I don't have time for too many details, but we validated the potential of this approach by comparing the process of manual digitization from satellite imagery in ArcGIS Pro with field survey data that we collected in the region. And so from this overview, we observed a positive relationship between warrens detected in imagery and those observed on the ground. So for rabbits, user accuracy was around 81%, meaning that most digitized warrens were correctly identified. Overall agreement accounting for emissions was around 49%. Of those, 79% of the emissions for rabbit warrens were attributed to warrens that were less than around 5 or 10 meters in diameter. So we're quite confident in our capacity to detect larger warrens, but there is difficulty as they get smaller. And so resolution of imagery, contrast with surrounding soil, or obscuration by other features such as vegetation are just some factors that influence our capacity to identify these features, and this is just a view from Google Maps. And so by looking at the strengths and limitations of what we currently have, we can better identify the ways in which the data can be appropriately used and what might be needed in order to facilitate its transferability and utility in the future. And so using this method, just to demonstrate, we've manually mapped individual rabbit and wombat warrens across a randomized subset of grids across the region. So for rabbits, we identified around 17,000 warrens, and I've also just included for reference the records that are available at the time from Atlas of Living Australia, just to highlight the different snapshot of extent, distribution, and density that you get depending on what approach, so opportunistic versus remotely derived or systematic sampling. And so sort of just an overview of what we're doing with it. We're using this data set and field data to examine broad-scale patterns of rabbit distribution, density, and activity. We're looking at temporal change, if we can detect that, rabbit behaviour at wombat warrens, using camera traps to see if there is a facilitating factor there, and also modelling potential drivers of broad-scale rabbit and wombat distribution as well to see what those influences might be. And so using satellite imagery, this can help to fill some major data gaps on burrowing species in very remote areas like this. And so by combining imagery with targeted field validation, we can create more baseline data information at broader scales than we've had before, and where other methods may have more cost and logistic constraints with accessibility. And so with advances in, say, resolution and availability of this kind of imagery, identifying how we can integrate this data and potentially use it in other areas will be quite interesting as well. And that's all I have. Thank you very much for listening.